In the last video, I was talking about how to decide if a relation is a function or not, and it mostly boiled down to decide if the evil two-headed arrow is happening or not. It's get a little bit trickier when we're just looking at an equation and we don't have any arrows or graphs to check out. So they start us out with this equation to think about. Y equals 5x minus 2. And we're supposed to decide if this is a function or not. You probably recognize this as a y equals mx plus b equation. If I graphed this, it would make a line. And in the last video, we were talking about a line. I was showing that a line passed the vertical line test and is a function. So if I were to graph this line, we got a y-intercept of -2 and a slope of 5. This line probably looks something kind of like that and passes the vertical line test. Anywhere I draw a vertical line, it only intersects that blue curve at one point. So passes the vertical line test, and therefore it's a function. If we think about this kind of with the evil two-headed arrow thing, if I were going to make an input-output table, an XY table, no matter what I plug in for X, it's always going to have one output, which is what the definition of a function is. Every input has exactly one output. If I plug in 2, 5 times 2 is 10, 10 minus 2 is 8, I don't sometimes get 8 and sometimes get -12, right? There's not the evil two-headed arrow thing going on. That never is going to happen with a line. I plug in a number, I get out one number always. Doesn't sometimes be one thing, sometimes be something else. So no evil two-headed arrow. Anything that is a y equals mx plus b equation like this is going to be a function. I think the only thing that we would need to think about as a line that would fail the vertical line test would be if the line itself was a vertical line, then we'd have problems. But any sort of tilted line, even a horizontal line, those are all going to pass the vertical line test. A slightly trickier example is an equation like this. This one says x equals y squared plus 1. All right, so this isn't something that we are familiar with yet. This is not the graph of a line or something we can instantly recognize. So what we need to do is we need to work on getting it into function form and see what happens. Function form, we're going to talk a little bit more about function notation as we go along, but this is like f of x equals whatever. Whatever the equation ends up being when we've got it in that form. Essentially what I mean is we want to get y by itself. I want to solve for y so that it's y equals something. And when I get y by itself, we'll be able to tell if this is a function or not. Let me show you what I mean. If we go through the steps to get y by itself, I'm going to subtract 1 off both sides. So I got x minus 1 equals y squared. And just because of I want this to visually look like what I want it to look like, I'm just going to switch sides here. So I'm going to write this as y squared equals x minus 1. All right, so I'm trying to get y by itself. And I only have one more step till I get y by itself. I need to get rid of that squared. So I need to square root both sides of this equation. And this is something I'm going to nag about all semester. Whenever you square root both sides of an equation, you always get plus or minus. So if I square root both sides of this equation, I have successfully got y alone. But what I've got on the right side is plus or minus the square root of x minus 1. This is the evil two-headed arrow in algebraic form, analytically. Instead of getting to see an evil two-headed arrow, this is what the evil two-headed arrow looks like when we're trying to work with an equation. Essentially what I've got is that y sometimes equals the positive square root of x minus 1 and sometimes equals the negative square root of x minus 1. That's exactly what makes something not be a function. That breaks that definition, where sometimes it's one thing and sometimes it's something else. I wanted to have a look at the graph of that equation, so I'm in the Desmos graphing calculator and I'm going to type in x equals y squared plus 1. Pretty easy to see here that this is not a function. Definitely fails the vertical line test. But we can do that without a graph by finding that y equals sometimes plus, sometimes minus. I actually want to check that out. Let's let's put in to this graphing calculator what we got from our algebra. So y equals sometimes the positive square root of x minus 1, and there's the top half of the sideways parabola. And if I put in y equals negative square root of x minus 1, there's the bottom half of that sideways parabola. So there's the sometimes it's the positive, sometimes it's the negative thing, and that makes it fail the vertical line test. So here is the top half, and here is the bottom half of that sideways parabola. Plus or minus is the evil two-headed arrow. All right, so I got one more example of deciding if an equation represents a function or not. This one says x squared plus y to the third power equals 1. So we're going to do the same thing that we did on this example. We want to put it in function form if possible. We want to get y by itself. So I will subtract x squared off both sides, and that will give us y to the third power equals 1 minus x squared. And one more step to get y by itself. I need to get rid of the to the third power, so I'm going to cube root both sides. And unlike even index roots, odd index roots like cube roots or fifth roots, they don't have that plus or minus thing going on. They're just a lot easier to deal with. Cube roots, we can cube root positive stuff, we can cube root negative stuff. We don't end up with the weird plus or minus situation. So all that happens here is we get y equals the cube root of 1 minus x squared. No plus or minus, no evil two-headed arrow, so this is a function.